All right, so today we're going to look at this is kind of the start of our next test. Rate of change, polynomial rate of change, and end behavior. So what's happening, increasing and decreasing. So how does the food industry set prices? So I just kind of like normal want you to take a second and try to answer these first three questions, and then we'll go through it. So take a second, pause the video, and try to look at the food industry is made up of a collective of diverse businesses that together make the majority of the food consumed by the world's population. How do these businesses decide which items to advertise and how much charge for each product? So take a second and see if you can answer these questions. All right, the lines below model the possible relationship between the price and number of customers for two popular supermarket purchases, baby formula and soft drinks. What do you notice about the two graphs? So we have our soft drinks and our baby formula. So looks like market is bigger for soft drinks. But what do you think? They're not willing to pay a bigger price. For the baby formula, they are definitely willing to pay more, right? So, all right, so which customer base, formula or soft drinks, is more swayed by an increase in price? How do you know? Probably soft drink consumers, right? So it's got a steeper slope. So the change in customers per price increase is higher. All right, so let's look here. Look at the data in the table below. Calculate the company's revenue for each item when the price is $10 and when the price is $45. So the revenue for 200 million, the revenue is 278 million. 30 and 52 million. That's what 2, 3, 4. Do you think it's a good idea for food companies to always charge more? So what do you think? So no. If you overcharge, you will lose customers. And make less. Food that is necessary for survival should stay priced more reasonably. What do you think? All right, number 3. The graph below gives the food company's revenue for baby formula. The x-axis represents the price of the formula. Label the y-axis revenue in millions, and the x-axis is price. And label the function r of p. Okay, so here is my price, and this is my revenue in millions. And then this function right here is r of p. Okay. All right. So is $20 the best price for the formula? So $20 is about right here. Is $20 the best price for the formula? No. No, r is increasing all the way to what? So it's increasing from 0 to 60. So from 0 to 60, it's increasing. So you could charge more. So do you see that it's increasing right here? So it is increasing right here from 0 to 60 right there. So okay, so it's increasing right there on that x-axis from the x values from 0 to 60. All right, is 80 the best price for the formula? So where's 80? So 80 is right here. So 80 is there. So what do you think? No. R is decreasing. So R is decreasing from 60 to roughly 120. So, and too expensive. All right. So, change my highlighter here. All right. So it's decreasing there. So from that point to that point, it's going to be decreasing. So on the x-axis there. If the goal is to make the most money, what is the optimal price? So the most money. So what is going to be that optimal price? And that's going to be $60, right? Because revenue is at its peak. So that's a relative max. Or in this case, it's, the maximum or the vertex of the parabola there. Okay. All right. At what price will the company make no money on formula? So no money on formula. So what do you think? So 0 and 117. So when P is 0 and P is 117. So P equals 0. That would mean that it's what? Free? Right? And then 117, way too expensive. Okay. So we're looking where that's going to cross the x-axis right there. Okay. So between 0 and 60, how much does the revenue change on average when the price of formula increases by $1? Explain. All right, so I want to find R. So on average, so from R, it's on an average increase. So R of 60 minus R of 0 divided by 60 minus 0. So that's what, I don't know, 2,500-ish. minus 0 all over 60 minus 0. So what's that? 41.6 roughly. Okay. All right, so this is rates of change. So that's an average rate of change from here to here because it's not constant, but it's an average. So it's not a constant rate of change like a linear function, but we are looking for, on average, what is happening to this graph, right? So what is happening to that graph? All right, so rates of change. So I'm going to try to draw this a little bit. So if I have a function, so I have an x1, x2, so this is the function evaluated at x1, and this is going to be the function evaluated at x2. So something like this. Then f increases on the interval from x1, the open intervals from x1 to x2. Okay, so this is called a domain interval, not a range interval. Okay. All right, so if we have something, so we have an x1 and an x2, and then this is going to be the function evaluated x1, and this will be the function evaluated x2. Then we say that the function decreases on x1 to x2. So this is still a domain interval, right? Domain interval. All right, and then the function, so x1 so now if the function is both x1 and x2 there, then we say that it's constant. So we are constant. F is constant. And it's still a domain interval from x1 to x2. All right, so a function is increasing on an open interval if the function x1 is less than the function evaluated at x2. So a function is decreasing on an open interval when the function value for x1 is greater than the function evaluated at x2. A function is constant on an open interval when they are going to be, when the function evaluated at those values are equal to each other. So relative extrema, so relative maximum, the y value of the point at which the graph of the function changes from increasing to decreasing. Okay, so relative minimum, the y value of the point at which the graph of the function changes from decreasing to increasing. All right, so the average rate of change of a function on a closed interval can be given by the average of the change. So it's roughly your slope formula. So y2 minus your y1 all over x2 minus x1. But here it's not constant, it's an average rate of change. So we will call this the function evaluated at b minus the function evaluated at a all over b minus a. All right. All right, so take a second and see if you can work through these 3 problems, and then pause the video and I will put the solutions up. All right, so here are the solutions, and I hope that you got all those right. Remember that when you give the intervals on which they're increasing, decreasing, or constant, they are domain intervals. So anytime you write the intervals, they are going to be domain intervals, so they're x values. Okay. For number 2, finding your x values where g of x is equal to 0. You're looking for your x-intercepts. And the relative mins, so the relative min would be about down here, and your max would be right there. And we always give when we're talking about a relative min or relative max, we are always talking about the y value. And then number 3, find the average rate of change for that function. So I need to evaluate it at g of 1, and I need to evaluate it at g of 6, and then subtract those values and divide by the change in my x value right there, say 1 to 6. All right, I will see y'all on Monday, and I hope y'all have a fabulous weekend.